So far, we've looked at angles which are formed by taking two lines into consideration, triangles which are formed by taking three lines into consideration. Then we looked at different types of triangles and their properties. And now we're going to look at a way of comparing figures. These could be triangles, squares, rectangles, any shape. The first one is a very simple definition. It says congruent figures. The figures that are exactly the same shape and size. It means all the characteristic features are the same. Recall, for example, in a triangle, the characteristic features were three sides and three angles. Which means if two triangles are congruent, then you have AB equals DE. You have AC equals DF, and you have BC equals EF. Similarly, you have angle A equals angle D, angle B equals angle E, and angle C equals angle F. Now, an important thing to note here is these are called corresponding sides. AB does not equal DF, it equals DE, because that's how you are going to overlap these triangles. Similarly, angle A equals angle D, it does not equal angle F. Yeah, so that's the idea of corresponding. For example, here, let's say I have these triangles ABC and FED or EFD. Question is, are they congruent? First of all, let's see. This angle equals this angle, 100 equals 100, and a 41 equals 41. So yes, they are congruent. And then AB would equal, now I have to be careful. A is corresponding to E, right? C is corresponding to D, and B is corresponding to F. So AB would equal EF. BC would equal DF. And AC would equal ED or DE. So it's important that you recognize which angles are corresponding. Another way to think about it is they are exactly the same, and to compare them you can sort of rotate this and make it look like that. And when you do that, this is going to be E, and this is going to be F, and this is going to be D. And then you can easily see that AB should equal EF, AC should equal DE, and BC should equal DF. The second notion of comparison is called similarity. To extend similar, you think of maps. What do maps do? They tell you relative distance between A to B, like on your phone. But that's not the actual distance. The actual distance is much bigger. Blueprints for buildings are smaller than the actual dimensions of the building. Or when you zoom in and out of pictures, the aspect ratio remains the same. Another example visually is to say that the black and purple figures are similar. So our intuitive notion is that they are not the same, right? But they share some property which makes them what we call similar. And this requirement for property is that the angles are equal in case of a triangle, and the length of sides are proportional. So they have the same proportion. And what are these sides? These sides are again the corresponding sides. For example, here we can say triangle ABC is similar to triangle DEF. This symbol here stands for similar because all three angles are equal, right? Namely, angle A equals angle D, angle C equals angle F, and angle B equals angle E. Which means that the corresponding side, so BC corresponds to EF. So if I divide BC by EF, it should equal AC, which corresponds to DF, and it should equal AB divided by corresponding DE. And let's plug in some values. What do we have? BC is 7 over EF. AC is 8 over DF is 4. And AD is 9 over DE. Now if I look at this equation, I have 7 over EF equals 2. Now 2 can be written as 2 over 1, and I can cross multiply. So 2 times EF equals 7, or EF equals 7 halves, which is 3.5 feet. Inches, sorry. Similarly, I can take this equation and have 2 equals 9 over DE. Again, writing as 2 over 1, cross multiplying, I get 2 times DE equals 9, or DE equals 9 halves, which is 4.5 inches. So my final result is that EF equals 3.5 inches and DE equals 4.5 inches. In the next video, I'm going to look at some more examples.